So in this lecture, we're going to talk about factorial designs. So a couple of lectures back, we talked about one-way experimental designs. And to refresh your memory, a one-way design is when you have just one independent variable. And with any variable, you have to have at least two levels. So for any one-way design, you can have two, three, four levels. And again, levels are also considered conditions. So for a one-way design, you have one independent variable. The problem with one-way designs is that in the real world, there are multiple causes for people's behavior. Not everything is due to just one independent variable. It can be due to multiple independent variables. And importantly, it could also be impacted by the interaction of various independent variables. But because a one-way design can only factor in one independent variable, it's limiting in terms of how much it can kind of capture the real world. And that's why it's important for you to understand factorial designs. Factorial designs are when you can have more than one independent variable. And importantly, an independent variable is called a factor. So when you see factorial designs or you see the word factor, just remember that a factor is also an independent variable, right? And the benefit of factorial designs is that it allows you to investigate more than one independent variable at a time, and it also enables you to look at the interaction between those independent variables. And we'll talk about interactions in a few minutes. Before we get too deep into factorial designs, though, let's make sure that you all understand some basic terminology. So a factorial design that has two factors, and again, factors are independent variables, is called a two-way factorial design. So it tells you that you have two independent variables, or two factors. A design that has three factors, or again, three independent variables, is called a three-way factorial design. And again, it tells the reader that you have three independent variables, and that the design is going to look at the independent effect of those three independent variables, but also the interactive effect of those independent variables. The next bit of terminology I need you to understand is oftentimes you'll see in a results section, you'll see something like, we ran a 2x2 factorial design. So I want you to understand what that's telling you as the reader. It's telling you that you have two factors, factor 1 and factor 2, right? The first factor has two levels, or in other words, two conditions. The second factor also has two levels or two conditions. So in total, this particular design has four conditions in it, right? Because you just multiply the 2 by 2. This is why the x is here. It's 2 times 2. So we have four conditions, also oftentimes referred to as cells. So the challenge in research methods is that they'll have more than one term for the same idea, right? So a condition, a cell, those are the same things. A factor, an independent variable, those are the same things. So the key is you're going to have to understand when we're talking about factors, we're talking about independent variables. When we're talking about cells, we're talking about conditions. You just got to get used to the terminology. So let's do another example so that you understand how this works. So the actual number itself, so a 2 by 3 factorial design, the number tells you how many levels there are in that particular factor. So this first factor has two levels. The other factor has three levels, right? So there's two factors total, one with two levels, one with three levels. Again, the levels we're talking about are conditions, right? So if we wanted to know how many total conditions there were in this particular design, you just multiply it out, 2 times 3, so there'd be 6. Let's look at the last one here. We have a 2 by 2 by 2 factorial design, right? So again, the number 2 indicates how many factors there are and how many levels there are in that particular factor. So in this first factor, there's 2 levels. For the second factor, there's also 2 levels. For the third factor, again, there are 2 levels. So in total, we have 8 conditions. 2 times 2 is 4, times 2 is 8. Right? So let's see how well you understand these ideas. So what I want you to do is I want you to figure out the number of factors, the number of levels in each factor, and the total number of levels or conditions there are in these different examples. The effect of race, black versus Latino versus white, and feedback, positive versus negative, on self-esteem. So, the first question is, how many factors are there? There's two. There's race and there's feedback. Those are our independent variables. For race, there are three levels: black, Latino, white. For feedback, there are two levels: positive or negative. So in total, we have 6 conditions or 6 levels. Right? Um, so this would be considered a 3x2 factorial design. For the second one, the effect of studying 10 hours versus 1 hour and sleep 10 hours versus 5 hours on exam scores. What are our factors? Our factors are studying and sleep. So we have 2 factors. Studying has 2 levels, 10 hours or 1 hour. Sleep has 2 levels, 10 hours or 5 hours. So it's a 2x2 factorial design, which means we have 8 total conditions. Then we have the effect of tuition costs, high versus low, college prestige, high versus low, and location, urban versus rural, on number of student applicants. So our different factors are tuition, college prestige, and location. So we have 3 factors. Tuition costs has 2 levels, high versus low. College prestige also has 2 levels, high versus low. Location has 2 levels, urban versus rural. So in total, it's a 2x2x2 factorial design with a total of 8 conditions. All right, let's do a little bit more. So a 2x2 factorial design has 2 factors, with the first factor having 2 levels and the second factor having 2 levels. And this design has a total of 8 cells or 8 conditions. 4 cells or 4 conditions. A 2x4 factorial design has 2 factors and a total of 8 cells or 8 conditions. A 2x2x2 factorial design has 3 factors and a total of 8 conditions. Just multiply it out, 2x2x2. All right, so for the example below, identify the research design. So if it's a 2x2 or a 2x3 or a 2x2x2, the number of levels within each factor, and the total number of levels or conditions. College students were randomly assigned to assess the persuasiveness of a message given either by an attractive or an unattractive person. While listening to this message, participants were seated in a room where there was a lot of noise or in a room that was quiet. So what's our design? So it's a 2x2 design. The first factor is attractiveness of the person giving the message. And there are 2 levels there. It's either an attractive person or an unattractive person. And then for the second factor, it is the noise level in the room. So it's either a quiet room or a noisy room. Right? So it's a 2x2 factorial design. Each factor has 2 levels and gives you a total of 4 conditions. So for this next question, researchers were interested in seeing if there were gender differences in how quickly men and women could type messages using different types of keyboards. Participants were randomly assigned to type a 30-word message on either a laptop computer keyboard, a cell phone keyboard, or an iPad touchscreen keyboard. So the design would be a 2x3, the 2 for gender, male versus female, and the 3 for the type of keyboard, a laptop, cell phone, iPad. So 2x3, and that gives you a total of 6 conditions. So now let's talk a little bit about main effects and interactions. So a main effect is the effect of one factor, in other words, one independent variable on the dependent variable, controlling for the effect of all other factors. So in essence, it's looking at the effect of one independent variable, not factoring in any other independent variables. It's just looking at that one independent variable. So if we have a factorial design that has 2 independent variables, a main effect is the effect of one of those independent variables not factoring in any effects of the other independent variable. So this is essentially analogous to a one-way design with where there's just one independent variable. So what you're doing is you're not factoring in the other independent variables, just looking at the effect of that one independent variable. For an interaction, it's a little bit more complicated. An interaction is when the effect of one of your independent variables depends on the level of another independent variable. So you can think of it as a joint effect of two or more independent variables on the dependent variable. So in a second, I'm going to give you an example about sunlight and plant growth. So the interaction would be that the effect of sunlight on plant growth depends on how much water the plant receives, right? So it's not simply a direct effect of sunlight on plant growth. The effect of sunlight is dependent upon how much water the plant receives. So to kind of give you a visual here, this is a bar graph. You can see when the plant is given a little bit of water, sunlight has no real impact on plant growth. But when you give the plant a lot of water, if you also give it a lot of sun, it has a stronger impact on plant growth. So in other words, the effect of sunlight on plant growth depends on if the plant received a little bit of water or a lot of water. With a little bit of water, sunlight has no effect. With a lot of water, sunlight has a more positive effect. And I now need to get you also to understand line graphs. So this is the exact same depiction of results, but using a line graph. It's going to be important for you to be able to view and interpret and draw both line graphs and bar graphs. So the endpoints of the line graph represent the four conditions. So what you're doing is you're plotting the means for the four groups, 1, 2, these two are the same, 3 and 4, and then you're just drawing a line connecting the means for those groups. The line doesn't really does not mean anything. It just helps you visualize the results. It really is all about the endpoints that are important, right? So the endpoints are essentially the same as the top of the bars in a bar graph.